Okay, so let's pick up where we left off of in 1.7, and we're going to look at this next slide covering another theorem. So this is called the congruent supplements theorem. So it talks about if two angles are supplementary to congruent angles or the same angles, then they are congruent. So in this picture here, we're saying that angle 1 and angle 2 are supplementary. They add to 180. And angle 3 and angle 2 add to 180. So let's say that angle 1 is 30 degrees. Right? Well, then angle 2 must be 150 degrees because 30 and 150 make 180. Well, if angle 1 and angle 2 are add up to 180, and angle 1 is 30 and angle 2 is 150, and angle 3 and angle 2 add up to 180, well, angle 2 cannot change, so it's still going to be 150. So what does angle 3 have to be? Angle 3 has to be 30 because 30 and 150 are 180. And now look, what do you notice about angles 1 and 3? Angle 1 and 3 are congruent. And that's exactly what this lands at. Okay. So if two angles are supplementary to the same angle, then they are congruent. That's the idea, right? Perfect. We can also do the same kind of idea with the idea of complementary, right? So the congruent complements theorem, same kind of idea, except now we're saying that the sum is 90. So I said here, what if angle 1 is 30 degrees? Well, if angle 1 is 30 degrees and angle 1 and angle 2 add up to 90, then angle 2 must be 60 degrees. And if angle 3 and angle 2 add up to 90, if angle 2 is 60, then angle 3 must be 30 degrees. And now you see that angle 1 and angle 3 are again congruent. Same kind of idea. Okay, so now time for some fun. We are going to perform a paragraph proof of this congruent supplements theorem. If angle 1 and angle 2 are supplementary, angle 2 and angle 3 are supplementary, then we need to prove that angle 1 is congruent to angle 3. And we're going to do this in what's called a paragraph proof form. And a paragraph proof is great because you can just use sentences. It's a little less structured than a two-column proof, but it might be a little bit easier for you because you're more writing it in conversational. Now, if you're one that doesn't like writing, then it could be a little cumbersome for you. I'm going to move that up here so I have all this space down here. So we'll just start with we are given. And I'll try to write my best. I am not one that loves writing. So we are given that angle 1 and angle 2 are supplementary. You'll notice I use some shorthand as we go through. And angle 2 and angle 3 are supplementary. Okay, so we are given that. So that's just given, okay? So now we're going to say by, now what does it mean to be supplementary? That means that they add up to 180. By the definition of supplementary angles, the measure of angle 1 plus the measure of angle 2 would equal 180 degrees. So that's the first part. And the measure of angle 2 plus measure of angle 3 equals 180 degrees. So you can see that each sentence is pretty much just like a row in your two-column proof, right? So the given were those statements. Now we're using the reason of the definition of supplementary angles to say these two statements. And now I hope you recognize this from the vertical angles theorem proof, because now I have two angle sums that equal 180. So now what we're going to do is use that transitive property. So by the transitive property, decide to write out the word this time, maybe because we're in paragraph form. By the transitive property, we can now say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. Right? Well, again, see that familiar measure of angle 2 on both sides, right? Plus measure of angle 2, it's a positive measure of angle 2. So in the next step, what we're going to say is through the subtraction property. Through the subtraction property, the measure of angle 1 will equal the measure of angle 3. That is by subtracting away the measure of angle 2. And therefore, and typically, like if I get to the prove part, I'll use like a therefore or a thus. And again, we want to prove angle 1 is congruent to angle 3. Well, their measures are equal, so that means that they're congruent. Therefore, angle 1 is congruent to angle 3 by, and that is the definition of congruent angles that you talked about way back in a previous lesson. And there you go. So that is a 1, 2, 3, 4, 5-step proof again, right? The given, the supplementary angles, the transitive property, the subtraction property, and then the definition of congruent angles. 5 steps again, but just written in paragraph form. No big deal. Okay. Cool. All right, so a couple more theorems to come at you, and then one more proof, and we are done with this section. All right. So let's see what we can do here. Let's bring this back down. All right. Okay, next one. All right angles are congruent, right? So this should be kind of common sense, right? Because if angle A is a right angle, it equals 90 degrees. And if angle B is a right angle, it is 90 degrees. That means that these two angles have the same measure. And if two angles have the same measure, then they are congruent, right? Should be not a huge surprise to you. The next theorem, so it says if two angles are congruent and supplementary, then each angle must be a right angle. So think about this, right? We have two angles, angle 1 and angle 2. They have to be equal to each other or congruent, and they also have to add up to 180. So the question really is, what two numbers, or what number, if you add it to itself, gives you 180? Well, that would just be 90 plus 90. 90 and 90 is 180. And that means that angle 1 and angle 2 are each 90 degrees, which means angle 1 and angle 2 are each right angles. Again, should not be surprising to you. It is a provable theorem, though. But there you go. The last theorem, and maybe an important theorem, is called the linear pairs theorem. Now, it's interesting that this book calls it the linear pairs theorem because in previous books, I have been called the linear pairs postulate. You understand that a postulate is something that is just accepted as true. This is something you can, I suppose, prove true, right? So here's the idea, right? The sum of the measures of a linear pair is 180. If you look at this picture, right? Angle 1 and angle 2 form a linear pair. They form a line. If they form a line, then that means that their sum is 180 degrees. So again, you have to think of this as it's a line, right? This is the line, which is also a straight angle. If you remember, we talked about different types of angles, and we should know that a straight angle is equal to 180 degrees. So that's why those two angles add up to 180. Again, if I take a look at this tool here, let me see if I click on this right here. Should take me to my interactive tool. And here we go. So obviously 145 and 35 is 180. If I move this, notice I can change the angle measures. But again, their sum always stays 180. I can go really, really small, right? Let's do, so 22 and 158. 16 and 164, right? Linear pairs theorem. Okay? All right. Cool beans. All right, let's get back to it. One last theorem to prove here, or one last proof to complete, and then we're on our way. All right. It says write a 2-column proof here. So we're given that the measure of angle 1 equals the measure of angle 2 in this picture, right? And we're also given that the measure of angle 1 is equal to 105 degrees. We want to prove that the measure of angle 3 equals 75. Well, right from the get-go, right, if I look at these two angle measures, 105 and 75, that's 180. So I'm thinking that in this proof, there should be some 180 action going on somewhere, right? So here's my statements and reasons for my 2-column proof. So the first statement is always the given, and I'll put both parts of the given. So the measure of angle 1 equals the measure of angle 2. And the measure of angle 1 equals 105 degrees, right? I throw the degree symbol on there. They typically assume you know degrees, but I don't like to assume things. And that's given to me. All right, so what can I do from here? Well, if I combine these, right, sorry about this. If the measure of angle 1 is 105 and the measure of angle 1 equals the measure of angle 2, that means they're the same, then I believe that the measure of angle 2 is also 105 degrees. And that would be truly, they call it the transitive property. I think that's a good substitution idea as well, but we're going to go with transitive property. Transitive property. Okay. All right, so now what do we do? Well, if I look at this picture, right, so I have angle 1 and angle 2 being 105s. Notice here how angle 2 and angle 3 are next to each other, right? I believe that they are a linear pair. Angle 2 and angle 3 are on this line. They form this line. Here's the ray going between them. So they're a linear pair. I believe by the linear pairs theorem that they are going to be supplementary. So in the book, I believe they kind of do like a definition of linear pairs and blah, blah, blah. I'm going to go straight to this. So from this picture, I know that the measure of angle 2 plus the measure of angle 3 is equal to 180. And I know this because of the linear pairs theorem. Notice we used this idea earlier. We used supplementary angles. That could fly too, but it's really the linear pairs theorem. So now how can I combine steps 2 and 3? Let me slide this up. Well, if you look at steps 2 and 3, right, here's angle 3, which might prove is 75. Here's angle 2. I know what angle 2 equals. Angle 2 equals 105. Let's take this 105 and let's replace the measure of angle 2 with 105. This is truly substitution. 105 plus the measure of angle 3 equals 180. Let me take off the degrees symbol there. And that is going to be by substitution. And now you can see, okay, well, if I get rid of that 105, if I subtract it away, I can do 180 minus 105. And when I do 180 minus 105, I will get 75. So step 5, by subtracting 105, we will get that the measure of angle 3 equals 75 degrees. And that is by the subtraction property. And there's our proof. So in my opinion, the more proofs you do, the better you get at them. So I'm excited to have you guys try this section out and see what you can do. All right. So great job at 1-7. Thanks for watching, and we'll see you in class.